My name is Matthew Meyer, and I'm with VMware PSO, and today I'm with David Noonan, and we're going to be presenting protecting the SMBs using SRM 5.0 with vSphere replication. Little disclaimer, this product is technically being developed right now. It is going to be released here shortly, but there could be some last-minute features that get fixed or removed from the final product. So how we're going to organize this session, I'm going to take the first part and go over an introduction of what VR is, a product architecture overview of the components that make up vSphere replication, and then go into the day-to-day usage of the product. I'm then going to hand it over to Dave, where we're going to go into some deployment scenarios and some architectural guidance in developing a solid disaster recovery plan, as well as some test lab results that we'd like to share with you. We do want to keep the session pretty interactive, though, so there's 2 mics here in the aisle. So if you do have any questions, please feel free to get up and use the mic, and we'll try to address it as we go through the session. And then we're going to leave a few minutes at the end as well to address any last-minute questions that you do have. So some stats that we discovered when we developed the session is that we found that 57% of SMBs don't have a disaster recovery plan. This was pretty alarming, but what was actually more alarming to me was the third bullet here, where 40% of businesses that do suffer a disaster and cannot gain access to their data within 24 hours are then out of business within a year. So it's not just important that you have a disaster recovery plan, it's that the plan is actually reliable and repeatable and that you can get access to your data within a really short period of time. So we know why disaster recovery is important, but why aren't people doing it? And that breaks it down into 3 categories, and the most important or the most compelling reason is cost. SMBs don't have the budget to deploy all the additional equipment needed to support a solid disaster recovery solution. And when you do develop or deploy all this additional equipment, now you have added complexity, and you have a recovery variability, where you think you're going to recover your solutions in a particular manner, but when it comes time to executing that disaster recovery plan, you find that something that you had planned for, you now have missed, and so you have a dependent upstream dependency that you didn't account for. So you're now faced with trying to recover systems that you didn't otherwise plan for. And then the personnel reason here was the testing of the disaster recovery solution. SMBs have limited IT staff. They just don't have the time to go out and run quarterly disaster recovery drills. And so this is not just relative to the SMB market. This goes all the way up to the full enterprises. We just don't have the time in today's constrained budgets to perform these types of tests. So how is SRM addressing these concerns now? So what we're doing is all these manual runbooks that go into creating a disaster recovery plan, and all of the manual steps in bringing an application back online and the servers back online is a manual process. So what we're doing is we're bringing that into a workflow tool within SRM that allows you to build a step-by-step workflow of your disaster recovery solution or your plan. We then have the ability to perform an automated disaster recovery plan put this in a workflow. So this eliminates the variability portion of disaster recovery. So now whatever's in that workflow, you know what's going to be executed at the time of recovery. And then third here, the non-disruptive testing, and I think this is one of the most compelling reasons to use SRM, is that you can do a non-disruptive test of your disaster recovery plan at your remote site without any impact to your production machines. You can bring them up into a test bubble network at your recovery site, and this allows you to use the same names and IP addresses that were at your protected site and not have any impact to your production workloads. So how is vSphere replication adding on or improving SRM. So with SRM today, we have to use a replicated storage platform. And so the responsibility of replicating these VMDKs are at your storage level. What we're doing is we're moving that up the stack to the ESX servers. So now your ESX servers are what's performing the replication. And so this allows you to use any type of storage platform that ESXi can use. And this can be even local storage, this can be Fibre Channel or iSCSI, or it can be even the VSA product that's currently been or recently released. Also, it allows you to use different types of storage at both locations. We can have a Fibre Channel SAN at your protected site, but we can have an NFS file share at your recovery site. The actual technology that goes into, or what the ESX servers are using, is not as relevant anymore. The replication is managed as a property of the virtual machine. So what we're doing is we're protecting each virtual machine on a per VM level and replicating that virtual machine. With SRM today, you have to protect it on a per LUN level. So if you were to storage vMotion that virtual machine around your protected site, you then lose the protection of that virtual machine if you moved it to a non-replicated LUN. Now that it is handled on a per VM level, you can move it all over your protected site, and it stays with that machine. And then finally here, the impact to your VMs is very minimal. Because the ESX servers are what's tracking the changes within your VMs, and we don't have any kind of an agent being installed on a per VM level, the virtual machine has no overhead associated with having to replicate those changes over to the recovery site. Some extra details on vSphere replication. We can replicate on a or each virtual machine disk can be replicated and included within that protection. So if we have a virtual disk or a virtual machine that has multiple VMDK files associated with it, we can exclude a VMDK to help reduce the amount of replication traffic that virtual machine is consuming. So for example, if we had an application that used a scratch disk, and you don't necessarily need that scratch disk in order to recover your virtual machine, but you find that it is using a lot of replication traffic because of that temporary data, you can exclude that from replication. And that way, when it comes back up on the recovery side, you have a assigned disk already for that, and by doing that, you're limiting your replication traffic. Now, getting the virtual machines to the recovery site, you have a couple of different options available to you. Traditionally, you would protect the virtual machine, and it would just copy the full sync over the wire. In some situations, you have a lot of capacity that you need to replicate, but you don't have the bandwidth necessary to get it over there in a timely fashion. So what we can do is we can even sneaker net it over, which is we can copy the virtual disk files to a removable device, walk them over to our recovery site, and restore the VMDK files to the ESX servers at that recovery site. Then when we go through and when we protect the virtual machines, we can then tell the wizard that the virtual disk file is already present at the recovery site. And then it just performs an initial sync to scan each virtual disk file to see that all the data is there. And so you can move many gigs over to your replicated site with minimal bandwidth available to you by doing it that method. You can place the virtual machines at any place at the recovery site as well. So if you have different tiers of storage at your recovery site, you can choose to use any type of storage available to you. And the virtual machines are protected in a consistent manner, meaning that if you have a virtual machine with more than one VMDK file associated with it, all those VMDK files are packaged and sent over in a consistent fashion. So that way your C drive is consistent with your D drive, for example. We've also simplified the management process when it comes to protecting your virtual machines. We don't require the administrator to define a replication window or a protection window for getting these virtual machines over to your recovery site. What we require is just you define the RPO. That's it. Once you define that, we intelligently determine how much bandwidth and when to schedule the replication for that virtual machine to get over to the recovery site and meet that RPO. We also have the replication specifics here. The changes for each virtual machine are tracked at the ESX level. So it's responsible for determining what change blocks are occurring, and then only the changes are sent over to that recovery site. So we're not doing any kind of a snapshot and then sending redo logs over to the recovery site. Every change block that gets tracked is then just sent over. And this helps reduce that bandwidth requirement and that replication traffic by doing it in this fashion. So we've got two general use cases for VR. First, obviously, is the disaster recovery model, where we would protect our virtual machines and bring them up. But we also have a new option available to us with SRM5, and that's the planned migration, or the workload migration. So what this is doing is it allows you to move your entire data center proactively to a different site. So if you're doing data center migrations, you're moving data centers, you're consolidating data centers, you can use this product to help facilitate that move for you. Also, if you're doing a planned migration, so for example, if you know a hurricane's coming, or if your psychic has told a CEO that there's going to be an earthquake next week, you can then move the workloads over to that recovery site without or help reducing or the impact to that virtual machine. What's nice about the workload migration method is you're ensuring that the disks are consistent at both sites. It won't allow you to finish the workflow if it detects that the replication is not consistent at both sites. So the requirements are all the components that make up VR. We have our ESX servers, and these must be ESXi 5 at both sites, and we have our vCenter server and our SRM server. It's very similar to how SRM works today, and you'll need those at both sites. But we've added the vSphere Replication Management Server, the VRS, or the vSphere Replication Agent, or server, and the VR agent. So here's a graphical representation of how those components lay out in the infrastructure. And what we're focused on here is the ones in blue, or dark blue, and those are the new vSphere component, or vSphere replication components. So as you can see, the VRA is what's responsible for checking out what change blocks are occurring, and they send the traffic over to the VRS, which accepts all of those changes, or all those change blocks. It then writes through the ESX server to the VMFS storage that's here at the recovery site. The VRMS servers, they're just responsible for knowing or mapping the source VMDK files to which destination VMDK files. If you're familiar with SRM today, it's similar to what an SRA is, and it allows SRM to use vSphere replication. So some more details on each component. We have our VR agent. Again, this is what's living on your ESXi hosts, and it's what's tracking the changes on each VM, and then sending those change blocks over to the VRA, which is sitting at your recovery site. Or the VRS that's sitting at your recovery site. So this VRS, the vSphere Replication Server, is what's accepting those change blocks and then writing them down through the ESX host at your recovery site. It's also maintaining your consistent image at your recovery site, and it maintains that one consistent image. So as replication is occurring, and if you had to kick off or execute your disaster recovery plan, you're ensured that VM at your recovery site is consistent. And that's what's responsible for this. And then again, the VRMS, this is also, actually I want to go back real quick. This here, the VRS, this is a Linux appliance. So this is a virtual appliance that gets installed by the SRM wizard when you deploy it, so you don't have to learn about deploying another application. Once you deploy SRM or you configure SRM, this gets deployed with that. And again, here's another Linux appliance or virtual appliance it's responsible for tracking or maintaining the mapping between the source and the target VMDK files. It's also in charge of monitoring the process and the status of the replication on each VM. So using the products is relatively simple. We have embedded the protection of having to or the ability to protect each virtual machine right within the vSphere client. So this is a tool that you're already familiar with using. So once you do right-click on the VM and you select the vSphere replication here on the bottom, you're presented with just a few options to protect that virtual machine and start the replication process. So the first thing you'll do is you'll define your RPO. And what this is just the amount of data that your business can tolerate losing. And then you have the ability to set a quiescing method. And at this moment, we have the ability to do any Microsoft VSS quiescing. This would be only applicable, of course, to the virtual machines that are Windows. And then you select your target destination location. The next is the ability to enable or disable the replication for this particular VMDK file. Again, if you had more than one VMDK file in your virtual machine, you would then have a couple of different more screens that you can enable or disable the replication for that VMDK. You again set the destination location where you want that VMDK to live. And then finally, you have the ability to set the type of data or the disk type. So you can have thick disks running at your protected site, but if you wanted to save space, you can run or you can use thin disks at your recovery site. The next step is defining what your VRS is going to be, your VR server. You choose where all of this data is being sent from your protected site and define where it's going to be sent to. That's going to be your recovery or VRS server. If you had more than one sitting at your recovery site, you would have this ability if you needed to scale that out. But in this case, we had two, so we would select one. The default is to auto-assign. That would just, what it does is it assigns based on a round-robin fashion of which VR server would be best suited for that virtual machine. And then finally, just a summary screen. So if everything looks good, you click Finish, and then you have a status screen. You've now protected that virtual machine, and everything's being replicated properly. So there you have a status screen here, and we have a couple of different statuses, what's going on here. We left them all in here to demonstrate that you have different statuses for VMs. And, well, green is good, so everything is going well, but then you can see that we have a yellow. It's very kind of hard to read here, but we have some yellow here. What this yellow means is there's just a warning. It means that, yes, the virtual machines are being replicated properly, but there's something that triggered an RPO violation. So for some reason, so much data was written to your protected virtual machine that your bandwidth couldn't accommodate. So you're successfully going to recover that virtual machine, but it might not be within that defined RPO. And then finally, we have in red an actual error, and there's a different reason for each error, such as the virtual machine disk file was no longer available. Somebody possibly could have deleted it. But what it does is it gives you the ability and the insight that there is an issue with the protection of that virtual machine. What's nice about this is that since we are using vCenter to piggyback off of all of this, we can use the alerts and the alarms within vCenter to inform the administrators that there is a problem, and then you can proactively know and go in here and try to fix it. And then finally, we have what happens when you really need to execute this disaster recovery plan. So this is the screen that you would be presented with. And now this is where I'm going to actually move the workloads over to the recovery site. This is when a disaster is declared, and you're then able to execute the recovery plan. But what we have here is a little choice that you have to make at this point. We have the planned migration, and we have the disaster recovery options. The disaster recovery option, what it will do is it will attempt to sync from the protected site to make sure that data is consistent. But if the protected site really is down, it will continue the workflow and bring up your machines at your recovery site. The planned migration, it's slightly different. What it will do is it will replicate the data, and if it can't, it aborts the entire process and allows you to go out there and figure out what's wrong. So now we've been through what the components are and how you would go and use it. And now I'm going to bring David Noonan up, where we're going to go over some deployment scenarios and some guidance around creating a solid disaster recovery plan. So thank you.
All right. Can you hear me? No? There we go. All right. So Matt has familiarized you with the components of vSphere replication and the benefits, but how would you go about deploying it in a real-world scenario? So we've highlighted 3 potential deployment options that we're going to go through over the next several slides. Private sites, which is where your organization would both own and maintain both the primary data center and the disaster recovery data center. The service provider scenario is where a service provider is providing disaster recovery as a service to its customers. And the branch office scenario, which is where you might have a distributed environment in your organization with multiple remote sites that require the ability to be protected from a disaster. So this slide is pretty much a mirror of the product slide. It's really the most basic and standard deployment mechanism scenario, where you would have a vCenter and SRM servers at each site. You would have a VRMS for each vCenter, so it's a one-to-one relationship with vCenter for each site, and that can support up to 500 virtual machines today. Also, the VRS server, as Matt mentioned, you can scale those out horizontally. It doesn't require a load balancer because it's using that assignment method. But it's unlikely that you would need to, because each VRS server can handle approximately 1 gigabit per second of throughput, and since their appliances are protected by VMware HA on your clusters. So here's the service provider scenario. In this scenario, you still have the same relationships of vCenter and SRM between your customer and the service provider, but this would allow the ability for the service provider to do some shared infrastructure in order to provide a cost-efficient service to their customers. And we had, actually Matt and I ran into a service provider, it was hosting.com, that is actually doing disaster recovery services today, but they plan to use vSphere replication in the future. And they have a session, I think tomorrow at 4 o'clock, right? So that might be interesting. Another point worth noting here in our examples, we have NFS storage at our remote facilities, which are replicated into VMFS block storage at the service provider, since you don't have that like-for-like storage requirement. So here's the branch office scenario. We took a little bit of a different approach on this one. So in the event that you had remote sites that likely have limited resource capacity, where running an SRM and a vCenter and a VRMS servers and consuming all those resources at each of those sites might be, you might not have that capacity to be able to do that, right? So in this scenario, what we're doing is, because we require those relationships for a protected and recovery site, but because we're not doing bidirectional replication, we're basically collapsing that and running it all within the central office to get away from that need and basically running a many-to-one relationship in that fashion. Also, you'll note here, basically, we're using ESX local disk in this example and replicating into VMFS block storage. So what are some of or how would you go about starting your disaster recovery design? Where do you get started? First thing you need to do is define your requirements and understand or identify your constraints. So just as an example, you need to identify how much data you're willing to lose for your systems based on priority, and how long those systems can be down. What is your recovery time objective? From a constraint perspective, you need to understand your data change rate, which is not always the easiest thing to do, and that's something we'll be talking a little bit about. And based on that data change rate, do you have the bandwidth available to be able to replicate those workloads? So some good practices and design considerations. The first thing you need to do is identify the systems that you're going to protect that are important, and identify the workload requirements. If you're replicating everything, then you need pretty much the same infrastructure at your recovery site. But if you can get away with doing a subset of infrastructure, then you need to analyze those workloads and determine how much capacity you need. And there's a couple different ways to do that. You could use a number of different performance tools, like PSO. We tend to use Capacity Planner. You could use vSphere and look at historical charting information from there as well. You also need to understand the impact of an RPO. So because data is not written evenly, probably in just about any environment, the burstiness means that it can definitely have an effect in a limited bandwidth scenario. So what I mean by that is, if you were setting a 24 RPO and you had a system that wrote extreme amounts of data, from 12 to 2 o'clock, that wouldn't be a really big deal, because a 24 RPO, as long as it can replicate all of that data within 24 hours, it's good to go. But if you have a very low RPO of like 15 minutes and you hit that bursty period of time, then you're going to have RPO violation after RPO violation, which is going to be an issue, right? So how do you identify the data change rate? Well, it used to be there were some tools, but you might use like incremental backups of your nightly backups to try to get a sense of what was going on, but that wouldn't be capturing paging information. One tool that we just learned about from a colleague named Joe just recently is CBT Tracker, which was written by Scott Harold. It's a PowerShell script available on vmguru.com. It's a really cool tool. What it uses is vSphere replication change block tracking to basically identify how much data has changed between 2 points in time. And what you can do is run that from a centralized point and run that script against multiple workloads and basically get a sense of what your aggregate data change rate is. And I have an example, there's an appendix in the end of this deck of basically aggregating those statistics and dropping them into a stacked area graph, which I'm very proud of because I'm a big fan of gradient, and it's very nice. So another thing you can do is take a VM snapshot. So if you know when the busy time is, it's a little bit more difficult, but if you had, let's say you're going after a 4-hour RPO, simply take a snapshot, make sure not include the virtual machine memory because that would throw you off. And then after the 4-hour period of time, you'll want to simply look at the data store browser and see how much that snapshot file has grown. And finally, the other option, which sometimes is the easiest, is simply pilot. Set it up, replicate across your link, and get a sense for whether or not it will work. So you can't really change how users are using your environment very much, and you can't typically change how the applications are behaving, but what you can have an effect on is paging. And paging can definitely impact your bandwidth requirements. So there's a couple options. One is, if you have the memory available, is right-size those virtual machines. But in the event that you can't do that, SRM does have the ability to manage the automation in a situation where you want to break that swap file out so it isn't replicated. And basically what you would do is have a swap disk at the recovery site that SRM would mount as part of the recovery process. It does require you to break out the page file onto a separate VMDK so that you can choose not to replicate it. But in some instances, you might have to do that if you're constrained by the bandwidth. Site connectivity. So the data stream today is not encrypted. So we don't encrypt that for you. So you'll need to use VPN or a solution to do that. But since we don't encrypt it, it is a candidate for WAN acceleration. And we've heard some good feedback from clients that were involved in the beta that said that they did have a positive experience from the vSphere application in reducing those bandwidth requirements. I also believe there's an announcement from Riverbed about that as well. So Let's see. Also, we have a number of alarms that we're kind of recommending here that are vSphere replication specific, around being notified when your RPOs are violated, when certain components are unavailable, or when replication's offline. So testing, this is important, and this really applies to standard SRM or vSphere application. Just about every engagement that Matt and I have been involved in have found that during that initial testing, the customer typically finds something that they weren't aware of. So maybe they had two different IP schemes, and they tested that application and found that there was some IP somewhere, and because it wasn't using a DNS name in every single instance, it couldn't work. So testing, extremely important. So it's also important to understand, whenever you're designing a solution, what are the limitations of the product that you're designing around. So some key limitations I want to note here are vSphere replication today only replicates powered-on virtual machines, with the exception of the workload migration. Also, snapshots are supported, but it's not going to replicate the tree of snapshots. The current state of the virtual machine at your protected site is the state it's going to be in at the recovery site. In addition, physical RDMs are not supported, which kind of makes sense, but virtual RDMs are. The automated failback that is built into SRM 5 is a new feature. It's called the automated reprotect, I believe is what they're calling it. That today is initially not going to be supported for vSphere replication. So you can imagine that that's probably coming. Another key point is, where does array-based replication still have its place? So if an example of that would be, you need synchronous replication. If you need synchronous replication, you're looking at array-based replication. In addition to that, if you can get away with a 15-minute RPO, obviously vSphere replication is a pretty solid choice. Consistency groups is another thing I want to point out. So in general, in a LUN, in a synchronous replication environment, every virtual machine inside that LUN is going to be write order consistent. You don't have to. So if you have two different systems that have data that need to be in sync at all times, you could simply put them on the same LUN and they would be consistent, right? So in addition, arrays often you can create consistency groups where you could bind those LUNs together. Today, what we can do with vSphere replication is all the disks within a VM are consistent from a write order standpoint, but we can't bind multiple VMs together into like a vApp and have it all be consistent with each other. You can imagine that's something that's probably being worked on as well. Last point on this one would be consistency agents. Today we only support VSS quiescing. And if you have an application that does not recover well in a crash-consistent state, that might be a consideration as well, a need for a different quiescing agent. So we did a lab test, just to kind of wrap up here, with as part of developing this presentation. And what we wanted to do was basically identify how vSphere replication would behave under a limited bandwidth scenarios, under different degrees of latency, and also just kind of get a sense of, under certain requirements, how many virtual machines could you replicate under those bandwidth constraints. So we went with the requirements that we configured for this lab were a 15-minute RPO. We went with a 5% data change rate over a 12-hour operational window for like a 20 gig of data size. So essentially 1 gigabyte spread over 12 hours of change per virtual machine. It's a private site type setup, so very standard Windows test virtual machines. And we had two tools that we leveraged for this. The RDFC, which is the random file data creator, which I put a link on there. And what that allows you to do is just generate files, right, of a bunch of data so that, And then also WAN Bridge, which is a wide area network emulator. What that allows us to do is restrict bandwidth and also delay packets to introduce that latency. Now, the only thing is that during the testing, I was having some trouble getting the latency to be consistent meaning when I applied both a bandwidth restriction using the tool and delaying packets, it just wasn't providing very good results. So not vSphere replication results, just in general, doing a ping test, it was all over the place. So what I did was we ended up just using WAN bridge for delaying packets and then use the distributed vSwitch to do the traffic shaping and do the bandwidth restriction. I was thinking about this, I might have also been able to stand up another appliance with WAN bridge and use one for bandwidth restriction and one for packet delay, but I haven't tried that. So here are the results. So as you can see, it handles latency quite well. So as we introduced even up to 200 milliseconds of latency, which I probably do better on my MiFi, even here with 200 milliseconds, it really handled that quite well. The degree of reduction in the number of virtual machines that we could replicate under these certain bandwidths didn't change much. However, to Matt's dismay, our test to the moon of 2,500 milliseconds of latency was not too successful. But that actually, as it turns out, it wasn't vSphere Replication's fault. So it was apparently, when I was doing some calculations, some online calculators, at 2,500 milliseconds of round-trip latency, the amount of bandwidth you would need for our change rate was something like a gigabit because of the amount of degradation that occurs. So in summary, vSphere Replication is a feature of SRM. It's easy to configure. It's like a 4-step process. It definitely opens up a number of deployment scenarios just because of that heterogeneous storage capability is a huge one. And the ability to do low-cost NAS, like all the different appliances that are out there, or local disk. It's pretty exciting. And low bandwidth conditions. I felt it did quite well, even when I accelerated latency all the way up to 200 milliseconds. Questions? Actually, before we jump into questions, I just wanted to, anybody that jumps out, I wanted to remind you to fill out the survey. We really want to know where we can improve and grow, so that helps us a lot. But in the back. Couldn't quite hear. I think it was, do we support compression for the data stream, for the replication? So we don't do the compression, but we definitely support the compression. Yep.
Do you need to take a snapshot of the VM before you do the replication?
No, it doesn't take a snapshot.
No snapshot?
No, it's just using its own mechanism. It's not actually using vSphere change block tracking either. It's its own mechanism that was developed before we created change block tracking, but it's its own mechanism, but there's no snapshots. Back? No, there isn't. You can configure the RPO. The throttling you could provide would be QoS. So I actually have, so I jump forward here. The replication traffic, as the appendix, is broken out into two different streams, a delta sync stream and a full sync stream. So you could apply some policies to that to prevent, like if you're going to do full sync, from interrupting your RPOs. And you could do QoS around it, but there's nothing built in to be able to provide that. Up here.
Is it supported with Essentials Plus?
I'm not repeating the questions, am I?
Yeah, the question was, is this supported with Essentials Plus? Yes, it is, but there are some caveats to that, because DRS isn't included with Essentials Plus. So when you do a recovery execute your recovery plan, it's not going to automatically figure out which host to bring that system up on. So you need to define and map out where you want that VM to be brought up. But yeah, it will work.
In the back, or the blue shirt.
So at the remote side, do you support a virtual vSphere? And if so, what are the dangers or advantages of that?
I think the question was, do we support a virtual vCenter? On the remote site?
Absolutely.
Yes, absolutely. Yeah, that's fully supported. We were introducing kind of a concept of what if you wanted to actually back that off and not use those resources, but it's definitely fully supported to have SRM, vCenter, and the VRMS all at the remote site.
The BSA is supported, right?
Yes. Yep. Yeah, anything that's on the HCL, basically it can put a disk, VMDKs, it's supported. And then there was, yep.
You restore the OS
If you restore the OS, oh, okay, so you have a replicated VM and you restore the OS. No, it wouldn't break anything as long as you didn't delete the VM or disable the replication. Obviously, it would probably create a pretty big requirement for bandwidth because of all those additional files you'd be copying onto there and install through the installation process. But black shirt? Have the small business tested at all? Oh, small business server?
Yeah, it's got the exchange.
Oh, okay. Yeah, I don't know. I know the guy I could talk to that was involved heavily, Michael White, who did who handled the beta, and he could probably really speak to that. So if you have any questions, come see me and I can get you guys in touch.
It should work. It's just that you'd have the same, I guess, things to look out for, like if you were to DR Exchange or SQL or anything like that. But I mean, it's OS agnostic of what you're protecting.
So the thing would be about consistency, perhaps, and since those are Microsoft applications, they should behave okay with VSS quiescing, so it should be okay. So, blue shirt.
Any changes to the licensing costs for small businesses, similar to Essentials Plus bundling or anything, or is it still the 195 standard?
It's just 195 standard that, per virtual machine.
There was the 75. Has that been talked about yet, or?
I haven't seen any.
Okay. I thought there is some new pricing. Have you guys heard anything? Or?
Yeah, there was a session just this morning. It's 195 up to 75 VMs.
Okay, yeah.
And 495 per VM.
Yeah, there's two editions. There's the standard edition and the enterprise edition. The standard edition allows protection of up to 75 VMs.
Okay.
And it allows you to use vSphere replication. And then you have the enterprise edition, which doesn't have that limit, but it's 495, but it gives you the additional array-based replications. There's also the planned migration option.
I think I skipped you a couple times. The blue shirt?
So I understand everything has to be on 5 at this point. My question is when 5.1 comes out, or maybe 6, and I have to upgrade, say I have a half dozen sites on the second, do I have to shut down all replications to upgrade and upgrade all of these centers and bring it all in? What's the upgrade?
I wouldn't think that would be the case. I'm not entirely sure. I know the update will be done through Update Manager, and since you should be moving your workloads around if you have a DRS cluster, and if that's what you have. So in that respect, the VMs can be vMotioned around and everything, and even storage vMotioned without any impact to that replication. So I don't know if you have any other.
No, I think it'd be okay as long as the VRA is compatible with the VRS server at the.
Now, when the VRS was being updated, that would probably cause a.
There would be. You'd have to definitely look at the order in which to upgrade to make sure.
Because the VRMS components can be totally offline. The VRA wouldn't be as big of a deal because the VMs can be vMotioned. But the VRS server that you're actually replicating through, during the time that was upgraded, there would be. I would think there'd have to be a short outage for that. So. Oh.
Go ahead.
Is that working? Oh.
So you mentioned there's no calculator specifically for figuring out how many machines I can put in a specific bandwidth. But as you're adding machines and you're modifying the RPO, will the interface tell you, you don't have enough bandwidth, or you just have to do it by manual?
Let's go to the interface. Let's go to the chart.
The interface does provide you some visibility. Oh, the chart? Well, the chart is of change block tracking of the.
Oh.
So, two things. One, in that interface that he showed you, the status screen, it provides you detail around the amount of time it took to conduct the last sync, how much data synced in that amount of time. So it gives you pretty good visibility to understand where you're at. So you would know, you could make some pretty good guesstimations, I think, off of that data that it provided. In addition, with that tool, if you wanted to do the proactive analysis with a CBT tracker, that was where I took basically and dumped those statistics into Excel that were running from that PowerShell script and basically just kind of charted it out so you can get a sense of where your aggregate change rate is. And that's really what you're most concerned about. It doesn't really matter what all the VMs are doing, but the peak is what you have to plan for, right? So, yep.
Do you support third-party duplication storage level?
Yes. Yep. Oh, sorry. The question was, do we support deduplication at the storage level? That answer is yes. Question?
API access to PowerShell and the Java SDK.
The question is, do we have API access to vSphere replication? I believe the answer right now is we don't.
I don't know. Yeah, I don't.
Yeah,
Well,
I don't
we can
believe
get back
so.
to you.
But that would be cool. Yeah, if we could basically leverage that and allow other third parties. Yeah.
Right, built it into another monitoring tool of some kind. Yeah,
You say flight migration is only supported with the enterprise license?
that's correct.
Okay. Any other questions? Anybody else in that black shirt?
Back to the small business scenario, we have sort of a template deployed at different customer sites that has the same IP scheme at different sites.
Okay.
It's simple. When you're having these multiple sites being protected at the center, we have to do IP which site we disaster fail weather.
You don't have to re-IP, that's an option that we offer, but we definitely have a number of sites. That'd be one example where you basically mimic the IP scheme, but there's also a number of sites today, customer here somewhere, his name's Russ or something, where they have layer 2 extension between the two sites, and then, we don't have to re-IP anything. In fact, it makes a very fast recovery when you don't have to. One additional advantage with SRM5, though, is we are doing we're no longer using sysprep to re-IP, so that process, if you had an experience with that being very slow, is improved dramatically from what I'm told. So, anything else? Good? All right.
All right, well, thanks.
Well, thanks, everybody. Appreciate it.